Next example of buffer style questions is when you take a buffer of known pH. In this case we're going to take the buffer from that you've just calculated. We know it to be 5.01 pH. What we're going to do is we're going to calculate the new pH when we take a buffer of known pH and we add a small amount of, in this case, acid. Again, the best thing to do is probably write down the Henderson-Hasselbalch equation, because ultimately we're trying to work out the pH, so we need to know the H+, and for a buffer it's always this. Now from this we can work out what we know and what we don't know. Now we know the pK because it hasn't changed from the previous question. We are going to need to work out what these two values are, because we're going to add more of the H+. And once we know these two, we can work out what this value is here. So the first thing we need to do is to work out the moles of H+ added. Now it's a diprotic, so it's MV over 1000, so it's going to be 0.5 times by 0.2 over 1000, and then the whole thing times by 2 because it's diprotic. So we are adding 2 times by 10 to the minus 4 moles of H+. So now what we need to do is think about the buffer solution itself. Now the buffer is going to consist of a weak acid that's in equilibrium. It's undergoing dissociation into A- and H+. And then we're going to come along and we're going to add this much extra H+. Now the system will oppose the change placed upon it by moving the position of equilibrium to remove the 2 times 10 to the minus 4, which means that the position of equilibrium will move in this direction. We will lose exactly the same amount of A-, but we will gain exactly the same amount of weak acid. Now if we look at the number of moles in the buffer that we started with from the previous question, you'll see that we had 0.009 moles of weak acid and we had 0.016 moles of salt. So add these on and you get 0.0092 moles of weak acid and 0.0158 moles of A-. Now those are moles, and they then need to be converted into concentration. Okay, so the way we do that is by dividing by the new volume. So in this case HA is going to be 0.092 divided by, well, we started with 50 and we added 0.2, so the new volume is 50.2, and then we times it by 1000. So we get a concentration of 0.183 moles per decimeter cubed of HA. Now A minus, exactly the same, 0.0158 divided by 50.2 times by 1000, and we get 0.315 moles per decimeter cubed, and that's for A minus. Back to the Henderson-Hasselbalch, last step, Henderson-Hasselbalch equation to work out what the H+ is. So Ka, we don't need to write it out again, we'll just put the numbers in, 1.74 times by 10 to the minus 5 times by concentration of HA, which is 0.183, over the concentration of A minus, 0.315, and we get 1.01 times 10 to the minus 5 moles per decimeter cubed of H+. Last step, pH is equal to the minus log of this fella, and we get 5.00. Now we started with 5.01, we added a small amount of H+, and because it's a buffer, oh you can see that now, because it's a buffer, we've seen very, very little change indeed.